Welcome to the Pre-Cal Trig Fall 2022 Unit 4 review. Hopefully you listened to my advice to wait until after whole group to take your first attempt on the test. After you've taken your first attempt, you can use this video to go back through your notes and make corrections before you take your second attempt. If you've already taken the Unit 4 test and used all of your attempts, but would like to improve your grade, you can also use this review with an example of each type of problem that you'll see on your test. Remember to use this video to help you study before taking your second attempt. You can use it to aid you as you take your first attempt, or you can use it to help you make test corrections to bring your grade up to a 70% if you don't pass either attempt on the part 1 of your unit test. All right, are you ready? Let's get started. Question 1. How can each logarithmic expression be rewritten? So we have a table here with 3 expressions. So we want to use our logarithmic properties. Those properties should be in your notes if you've been going through the course content. But they're also in the Quizlet study set for this class. So we want to evaluate each statement and determine whether it's true or false. So let's look at the first statement. Log base 3, c times d raised to the 4th power. And we want to know if that equals this expression here. So let's use our logarithmic properties to analyze the left-hand side and see if we get what's on the right-hand side. So the first thing that we're going to look at is we're raising this CD to the power of 4. So we can bring that 4 up to the front. And with the product rule, we can write this as log base 3c plus log base 3d. So let me write this that way. 4, we've already brought this power up to the front. So we have 4 times log base 3. Using our product rule, we write this as addition plus log base 3. Forgot to write my c here. Log base 3d. All right, let's look and see if that's what we have here on this side. All right, we have 4 times log base 3c, but we don't have a 4 times log base 3d. So in order for this to be correct, we would have to distribute that 4 to both of these. So what they've neglected to do is write parentheses. So that's going to be a false. All right, let's go to the second line. We've got 2/3 natural log A plus natural log B. And using that power rule, we can bring that up over here and write that as log base A plus natural log A plus natural log B to the 2/3 power. The product rule, we're going in reverse now, means that we can write this as the natural log, let me move over here to the right, the natural log of A times B. And then remember, we've taken this as the exponent. So what that means is we're going to be taking the 2/3 root. So let's analyze this. All right, the bottom number is going to be the root. The top number is going to be the power. So that's going to be a squared, b squared, and we want the cube root of that. Let's see if that's what we have here. Natural log, we've got the cube root, a squared, b squared. So that's a true statement. It's really important that you have those rules with you and that you've practiced. It makes this a lot easier. Let's go down to the third one. Take your time on these. We have the natural log of e to the third power over f. Now this is division. Fractions are division. So this is the quotient rule. When you have 1, we have the e to the 3 on the top and the f on the bottom. Then this is going to be subtraction. And we do have, if you look on the right, we do have subtraction. But let's look at the left here and let's simplify this and see if it matches the right. So this is going to be the natural log of e cubed minus f. And because this is inside of the parentheses, we can't bring it out to the front. And that's what they've done here. Let me look at that a little closer. Let's write it the way that they have it. All right, they have natural log e to the third. So maybe that will, let's go slow. Let's go back and look at that. Natural log of e to the third power minus the natural log of f. All right, so now this is starting to make sense. We can bring that 3 out, which is what they have here. This matches up. And this matches up. So that does look true. You see how I almost looked at that the wrong way? So again, take your time, use your notes, go slow, don't try to rush through this. So this would be a true statement as well. For question number 2, we have an invertible function represented by the values in the table. So here are the values, our x and our, remember we can write this as y, our x and y values. So we want to invert those. We want to switch the x's and the y's. So this becomes the y, and this becomes our x. So we're going to start with this bottom point, and we're going to try to find the graph that matches it. So let me start with something easy. We'll start with -1, 0. So -1, 0 is right here. That looks like it's a go. But this graph also has -1, 0. So that doesn't eliminate one or the other. You'll probably have 4 to choose from, but I'm trying to eliminate the ones that don't work. So let's just move to another point. I'll move to this one. Doesn't matter, wherever you feel most comfortable. So remember, we're going to start with this. This is our x. So this is -0.8. It's a little bit closer to -1 than to -1/2. So I'm going to start here and go to -0.8. It's a little bit less than -1, and then go up to 1. So that looks like that could be a possibility. But on this one, if I go to -0.8 and then up to 1, this is a no. I'm going to try another one just to be sure. So let me see what point I want to try to test. Let's try this one. And let's go to the graph that I think it is. Try that third point. All right, we're going to start at the bottom. Remember, we've switched the x's and the y's. So 0.6 in the positive direction. So that's a little bit more than 1/2. Go a little bit more. And then go up 2. 1, 2. So that's the third point that checks. If you want to go ahead and check all the rest of those, 4.4. So go here almost to 4.5. And then up to 3. So that checks as well. And then you can see that this does not. So it's going to be this solution here. All right, question number 3. We want to enter our answer in the box. We want to solve this equation. So if we look at this for a minute, take a minute and look, and it looks like our base is probably going to be 7. So let's test that theory out. We can write this 7, of course, as 7 to the first power times 7. And we know that with our exponents, practicing with our exponents as we have, the square root of 7 is 7 to the 1/2 power. Remember that 1/2, the bottom is going to be our root, the top is going to be our power. All right, now we have all of that, expanding that out, and I can see that I do have a base 7. So we're raising that to the negative 2x plus 1. So that's the left-hand side. Now let's look at the right-hand side. So if I've got 1/7, how do I write that? This right here, I'm looking at 1/7. How do I write that as a power of 7? That's going to be 7 to the negative 1 power. Okay, a negative exponent means we're going to flip this upside down, this fraction, and write it as 7 over 1. And then let me start with the 7. Trying to look for some room. Okay, 7 over 1 to the negative 1. We flip this upside down and write it as 1 over 7 to the, and then the exponent becomes positive. Now, when we raise something to the first power, we just drop that off. So this is going to be 1/7. So 1/7 is 7 to the negative 1 power. Okay, now let's look at 343. Get your calculator out. 7 times 7 is 49. Times 7 is 343. So 343 we can write as 7 to the 3rd power. Now let's be real careful and put that in parentheses because we're raising that 343 to the x minus 3 power. When you raise a power to a power, you multiply the exponents. So this is going to be 3 times x. So let's rewrite this as 7 to the 3x minus 3 times 3 is 9. You've got to distribute that all the way across. All right, so we've rewritten that. And then we have the same base. When we multiply two numbers with the same base, we add those exponents. So let's take those exponents. I'll take the 3x minus 9 and write that down. And then we're going to add this exponent here. We're going to add a negative 1. So negative 9 plus a negative 1 is negative 10. 3x minus 10. And our base is 7. So this is the bottom one. All right, remember the top number, or the, not bottom, the left-hand side, when we simplified this, let's see if I've gotten this simplified yet. I don't have this simplified yet. I'm trying to go too fast again. So this is 7 to the 1/2 power. Maybe I better start over on this. It's starting to get tired. Let me just back up and erase everything. I see where I'm going, and I don't want to. Okay. Don't want to confuse you. All right. Question number 3. We want to solve this equation. So take a minute and look at that. we want to try to determine if we have a common base. And it looks like our common base is going to be 7. But let's investigate a little bit further and see if I can simplify this with a base of 7. So 7 is 7 to the first power times the square root of 7. That's 7 to the 1/2 power. I'm going to put that in parentheses as it is right here. And all that's being raised to the negative 2x plus 1. Let me just look at that for a minute and keep simplifying that. So let me move in this direction. All right, let's start here in the parentheses. When we multiply the same base, we add the exponents. So 1 plus 1/2 is 1 1/2. I'm going to write this as an improper fraction. Now listen carefully, because it's very important when we're dealing with exponents and logarithms to keep your answers as an improper fraction. Simplified down to the improper form, but don't write it as a mixed number. All right, so 1 plus 1/2 is 1 1/2. Write it as 3/2. So we're adding those exponents. So that would be 7 to the 3/2. All right, so we've simplified what's inside the parentheses. Now we're raising all of that to the negative 2x plus 1. All right, so when we raise a power to a power, we're going to multiply. So we need to distribute that 3/2 to the negative 2x and to the positive 1. So we're going to multiply 3/2 times negative 2 over 1. You'll see the 2 cancels. We have negative 3. That's all that's left right there. And then 3/2 times 1 is 3/2. Oh, I forgot the x over here. Now let me write that a little bit nicer. So we've got negative 3x, because this was negative 2x. So you got that 2 that cancels. You've got negative 3, and then don't forget the x. And then when we distribute the 3/2 to the 1, it's just plus 3/2. 3/2 times 1 is 3/2. So this is 7 to the negative 3x plus 3/2. Now we're going to work on the right-hand side. So we're going to take that 1/7 and we're going to convert that to a power of 7. This would be 7 to the negative 1 power. Remember that when you're raising something to a negative exponent, we'll take that 7, we'll put it over 1, we'll write the reciprocal, and then the power becomes positive, changing that to 1/7. So 1/7 is 7 to the negative 1 power. Now let's see if we can factor 343 into a power of 7. Get your calculator out. 343 divided by 7 is 49. Divided by 7 is 7. Or you can do it in reverse. 7 times 7 times 7, or 7 to the 3rd power is 349. That's what, 343. That's what this is. Let's just stop right there for a minute and multiply these two things together. Or can we? No, we need to look a little bit closer. Don't go too fast. We need to, since we wrote this as 7 to the 3rd power, we need to go ahead and raise that power to the power of x minus 3. So this is to the power of x minus 3. Distribute that 3. 3 times x is 3x. Get my eraser and erase that parentheses there. And let's just go a little bit slower. So let's keep that 7 to the negative 1 times 7. 3 times x is 3x. And 3 times negative 3 is negative 9. All right, just do a double check. Make sure that we've got everything. We've got this, that's 7 to the negative 1. 7 to the third, and we raise that to the power of x minus 3 to get this right here. Now we can go ahead and we're multiplying the same base. We would be adding these exponents. So let's just go ahead and add that negative 1 to this right here. Negative 9 plus negative 1 is negative 10. So this is 7 to 3x minus 10. All right, just double check that. 3x minus 10. All right, so this is the left-hand side. This is the right-hand side. We have the same base. So we can drop that base and just write this equation. Negative 3x, this part right here, negative 3, the exponent, negative 3x plus 3 halves. Let me erase a little bit, give myself some room over here. Just go ahead and erase all of this over here. So we've got some more room to work. Set up my equation. All right, let's take that exponent, negative 3x plus 3 halves. I got a little gung-ho there. I need a little bit more room. Erase this part too. Is equal to, the other exponent is going to be 3x minus 10. All right, now we work on solving that. So I'm going to add 3x to both sides because I like things to be positive. So if I add that to both sides, this is going to cancel out. This is 0. Bring down the 3 halves. So 3 halves is equal to 6x minus 10. Now we want to add 10 to both sides. So we'll get 6x on the right-hand side, and on the left-hand side we'll get 10 plus 1 1/2. Let me go ahead and change this, but this is 10 over 1. Find a common denominator, and it's going to be 2, so I'll go ahead and multiply by 2 over 2. Remember I said earlier we want to keep things improper when we're dealing with exponents and logarithms. So this is going to be 20 over 2 plus 3 over 2 is 23 over 2. So the left-hand side is 23 over 2. This side, we've got 6x. We want to isolate that x, so divide both sides by 6. Remember, that's the same thing as multiplying by 1 over 6. So when you're dividing by 6, it's like multiplying by 1 over 6. I'm going to go ahead and write it this way on the left-hand side. On the right-hand side, we have x is equal to, now nothing's going to cancel. 23 times 1 is 23, and 6 times 2 is 12. So your answer is 23 over 12. A warning ahead of time, if you write this as a mixed number, it's going to get counted wrong, as it should, because you need to listen and follow the rules for exponents and logarithms. All right, let's try another one just for practice. So I want this to sink in. Do not write this as a mixed number. Go through this a little bit faster. All right, so this is 5 to the first power and this is 5 to the 1/2 power. Now, because both of these are in parentheses, we need to go ahead and add these first. So this is 1 is the same as 2 over 2, plus 1 over 2 is 3 over 2. So keep that improper. So this is 5 to the 3/2 power. Now we're raising all of that to this power, so we need to multiply the 3/2 to the negative x plus 3. Raising a power to a power, you multiply. When you have the same base and you're multiplying, you add the exponents. All right, so 3/2 times negative x is negative 3/2 x. And then 3/2 times 3 is positive 9/2. All right, I think I did that right. Going kind of fast, but if I made a mistake, I'll go back and find it in a minute. You just take a minute and double check. It looks right. On the right-hand side, we've got 1/5. That's 5 to the negative 1 times 125 is 5 times 5 is 25 times 5 is 125. So that's 5 to the 3rd power. And then we're raising that to the 2x minus 3. So take that 3. Raising a power to a power means we're going to multiply these exponents. 3 times 2, that becomes 6x minus 3 times 3 is 9. All right, now, okay, remember when we're multiplying the same base, we add the exponent. So I'm going to add that negative 1 to the 6x minus 9. So let me just add that negative 1 over here. So negative 9 plus negative 1 is negative 10. So we have 6x minus 10. All right, now we can take the left-hand side because we have the same base 5, and we can write those exponents as an equation. So negative 3/2 x plus 9/2 equals 6x minus 10. All right, I want to go ahead and, what do I want to do? I want to go ahead and add 3/2 to both sides. So that's going to become a 0. So when we add, that's 3/2 x. So when we add 6x, let me move up here to the left so where I've got some room so you can see it. When I move that over here and add it to the 6x, put 6x over 1 plus 3/2 x. Find a common denominator. It's going to be 2. So multiply by 2 over 2. You get 6 times 2 is 12x on the top and 2 on the bottom. So 12x plus 3x is 15x over 2. Got a minus 10 over here. I'm going to go ahead and add that to both sides. So you've got 9/2 over here plus 10 over 1. Again, keep that improper. Find a common denominator. It's 2. 2 times 10 is 20, plus 9 is 29/2. So 29/2 on the left is equal to, let me see if I can remember what we got over here. 6x plus 3/2 is 15x. Let me go back up here and double check. Yes. Okay, 15/2 x. All right, remember we're solving for x, so we want to get rid of whatever's next to the x. So we're going to multiply by the reciprocal, 2 over 15, to solve for x, and we'll get x is equal to 29 over 15. All right, again, it's important to keep your answer as an improper fraction. Now, if you can find something that divides evenly into the top and into the bottom, you can simplify it, but don't go as far as writing it as a mixed number, or the computer will count it incorrect. For question number 4, there are steps for graphing the logarithmic equations. Now, I can anticipate, because we did this last year, that this might be one of the more difficult problems, but I want to encourage you to use your Desmos graphing calculator for checking your answer. Try first with these steps, check your answer, or if you're completely confused, it's okay to go to Desmos. I'd rather you go to your graphing calculator than to go online and Google an answer, because that is just going to be more confusing for you. So let's look at this one and let me walk through the steps with you. All right, you're asked to graph or find the graph of the function f of x equals negative natural log x plus 1. Now, it's important that you really look at this for a minute so that you'll know what order to go in. So there are no parentheses around the x plus the 1. So we're not grouping those together, because that would be like making the x plus 1 part of the exponent. So this is off to its side. Let's save that for last. Let's start by graphing the parent function. And the parent function, strip everything away from ln x and just graph f of x equals ln x. So we're going to go over here, replace the f of x with y, and graph y equals ln x. So we're going to set up the exponential equation for y equals, remember what ln, the natural log of x is. That's log base e of x. Now take the e, bring that to the power of y. E to the y equals x. So the asymptote is y equals 0. This line right here. Instead of the asymptote being the x-axis, it's the y-axis. Everything's going to invert. All right, so now that we have this, e to the y equals x. Remember, this is always, this number that's on this line right here next to the base is always our answer. This on the other side of the equal is always our exponent. All right, so now that we've got that set up in exponential form, and we know the asymptote is y equals 0, or the y-axis, let's plug in some values for y. We're not going to start with x this time, because it's going to be difficult if we start with x to find y. So let's choose some numbers that are easy. I'm going to start with 1. So let me go over here where I chose 1 for y. Plug that in. E to the first power is e. Now, in order to graph that, we've got to get an approximation. And we know the approximate value of Euler's number is 2.718. So we have 1 point right here. Now, another choice I'm going to take is 0. Put 0 for y. Anything raised to the 0 power is 1. So x will be 1 in that case. I'm going to choose one more. I'm going to let y be negative 1. So when we have a negative exponent, that's going to turn this into a fraction. It's going to be 1 over e. And E is approximately 2.718, so that's about 1/3. I used my calculator to get a closer approximation, 0.368. You don't have to get really, really close. You can use 1/3. All right, so when y is -1, x is 0.368. So that's the blue line. You see I plotted those 3 points here. 1, 0, 2.781, 0.368, -1. Now, this is taken from Desmos because I do want to encourage you, don't think you're cheating when you use your calculator for this to check. But I want you to start understanding what's happening here. This is an introductory course. You don't need to master it. You just need to understand it, what we're doing here. All right, so step number 2 is we're going to introduce the negative of ln x. So what that means is we're going to set up this exponential equation for negative log base ex, just like we did here. So this is going to be e to the y equals x. Now, the shortcut is to make each y value its inverse, or the negative, or the opposite, however you define that. So we're going to take these numbers up here, and whatever the y is, we're going to make it its opposite. So 0 doesn't have an opposite. So we'll still have 1, 0. We're looking at the black line this time. Okay, so that we still have this point here. Go to the second point from the parent function, take the y value, turn it into its opposite. So we're going to have 2.718, -1. So that's going to be right here. So it's just going to mirror itself over the x-axis. Okay, the last number is 0.368, -1. So we're going to make that -1 a +1. Again, it just mirrors over the x-axis. All right, so now we can kind of sketch that graph with the black line. Now the last one, I didn't put the points on here. We're going to go through this together. Is that final piece where we're going to graph. We've already got negative ln x, and then we're going to put +1. Now, if you remember the exponential rules, let's convert those to the logarithmic rules. We're going to add 1 to each y value. We're not going up and down. I'm sorry, we're not going left and right. We're going up and down. So where we had a 0 here, we're going to add 1. Okay. So let's start right here, and we're going to go up 1. Okay, so that's going to be 1, 1 right here. Okay, the red line is where we're going from the black line. The blue line was our parent function. So let's just look at the black line. I'm going to this number, 2.718, and I'm going to add 1 to -1, and I get 0. So that's basically just shifting everything up 1. See how we're doing that? Okay, I'll go to this point, 0.368, 1, add 1 to 1, and you get 2. So that's shifting it up here. So this is a sketch of this graph. F of x equals negative ln x plus 1. All right, again, don't get stuck on the graphing. Use Desmos. Don't be afraid to use Desmos, but please stay away from Googling answers because that could get you off track. All right, question number 5. What is the value of the logarithmic expression? We want to write this as 4, let me just write it this way. Log base 4, 1 over 64 is equal to x. So we're going to use that circular pattern. 4 to the x power equals 1 over 64. So we're going to write it in exponent form. So 4 to the x equals 1 over 64. We're evaluating this as 4 raised to what power equals 1 over 64. Well, the first thing I'm going to do is look at this, and I'm going to know right away that this is going to be a negative number. is 64 a power of 4? Let's test that theory out. 4 times 4 is 16. 16 times 4 is 64. So 4 to the third power is 64. So 4 to the negative third power would be 1 over 64. So our x would be negative 3. So what we're saying again, let's just test that theory. 4 to the negative third power equals 1 over 64. Answer is negative 3. Let's try another one. Same question, question number 3. So we're saying basically 2 to what power is 1 over 64? 2 to the x is equal to 1 over 64. Let's see, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. Double check that on your calculator. All right, so this is 2 to the 1, 2, 3, 4, 5, 6 power gives us 64. To turn that into 1 over 64, we need to make this 2 to the negative 6. So x is equal to negative 6. All right, question number 6. What is the equation of the asymptote in the graph of the exponential function? All right, we basically take this equation and whatever we are adding or subtracting, we set that equal to y. So y is equal to negative 1 is the equation of the asymptote. Let's try it again. All right, the asymptote is y equals, this time, positive 4. That's the equation of the asymptote. Question number 7. What is the solution to the equation natural log x minus natural log 2x minus 3 equals natural log of 3? Now remember your log rules or log properties. When we're subtracting, it indicates division. So we're going to rewrite this as the natural log of x divided by the natural log of 2x minus 3 is equal to the natural log of 3. All right, well, let's just go ahead and take that out and set up our equation. Let me move up here. So we have x over 2x minus 3 is equal to 3. All right, now what do we do here? We want to get rid of that fraction because we have a variable in the denominator. So we're going to multiply everything through by 2x minus 3. And we multiply this side by 2x minus 3. It will cancel out that variable in the denominator, and we're just left with x equals. Go ahead and distribute the 3 times 2, 6x, and then the 3 times negative 3 is negative 9. All right, continue to solve this. We want to subtract 6x from both sides. You can do it a different way. You can subtract x from both sides, add 9 to both. It doesn't matter where you go from here. As long as you follow the rules, you'll get the right answer, the algebraic rules. All right, negative 6x plus positive x is negative 5x. So we have that on the left. On the right-hand side, we have 0. That's equal to negative 9. Divide both sides by negative 5. So we have x is equal to 9/5. Again, a lot of this is about going back to your logarithmic properties. So make sure you have your notes with you. Let's just go through another one for practice. Again, we have the same base. All right, so we have subtraction. Subtraction indicates division. So I'm going to go ahead and pull this out in front of both of those. Just skip a step in simplifying. So we have the natural log of x over 3x minus 3 is equal to the natural log of 2. Let's take that out and set up our equation. So we have x over 3x minus 3 is equal to 2. Multiply both sides by 3x minus 3. It's going to cancel out on the left-hand side. And we've got 2 times 3 is 6x. 2 times negative 3 is negative 6. All right, now this time I'm going to subtract x from both sides. Just a different way to approach this. Following the correct rules for solving equations. All right, so on this side we have 6. On the right-hand side we have that negative 6 plus 6 is 0. 6x minus 1x is 5x. We're almost there. Divide both sides by 5, and you get x is equal to 6 over 5. All right, what is the value of this expression? All right, so what we're saying is we're evaluating, let's see, we have the same base here. When you have a base and a log, raising it to the power with the log in it, this goes away. So this is 3 to the 4th power. So we're evaluating 3 to the 4th power. 3 times 3 times 3 times 3 is 81. Let's try another sample. All right, so base, log base 4. So we're evaluating 2 to the 6th power. 2 to the 6th power is, we saw this earlier, 64. All right, we want the inverse of f of x equals this equation right here, 2/3 x to the 3rd minus 1. So we have 3 steps. We're going to write f of x as y, and we're going to swap the x's and the y's. Let me go ahead and do that here to save space. We'll go ahead and write that as an x, and we'll write the x as a y. All right, now the next step is to solve for y. All right, so we're going to add 1 to both sides. Let me just go ahead and flip these sides. So we have 2/3 y to the 3rd. On the right-hand side, which I'm going to flip over to the left-hand side, and that negative 1 plus 1 is 0. So we're just left with 2/3 y to the 3rd. And then I'm going to put this over on the right-hand side and write it as x plus 1. Okay. All right, now I'm going to multiply by 3 over 2. So we've got to multiply all of that by 3 over 2. So this cancels out, and we have y to the third equals 3/2 x. Let me just go ahead and write it like this. 3 times x plus 1 over 2. Okay, and then we take the cube root of both sides. And we get the cube root of 3x plus 3 over 2. Question number 10. We want to solve this equation. Log base x 1 over 32 equals 5. So again, remember this is x raised to the 5th power equals 1 over 32. So let's write that in exponent form. X to the 5th power is equal to 1 over 32. So what we're saying is, oops, not 1 over 35. My pen back here, 1 over 32. All right, so what number raised to the 5th power is 1 over 32? I know it's going to be a fraction, and I know that that numerator is easy. What number to the 5th power is 1? So that's going to be 1. 1 to the 5th power is 1. But what number raised to the 5th power is 32? Let's try 2. All right, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. 1, 2, 3, 4, 5. So yes, it's 1/2. So x is equal to 1/2. Now, does that look right? 1/2 to the 5th power is equal to 1 over 32. Go through these slowly, carefully. All right, what is the solution to this equation? Same kind of problem. X to the 5th power equals 32 over 243. So what we're thinking is what number raised to the 5th power gives us 32 over 243. So we're going to break apart the numerator. 2 to the 5th power, we just saw that is 32. And what number, is there a number raised to the 5th power? Get your calculators out and take the 5th root of 243 and you'll get 3. So this is 2/3. Okay. And we're looking at ln of 6 over 3 and asking you, on your test, you'll be given 5 or 6 different kinds of expressions to match up with what's equivalent to this. So let's just take what we know. And we can write ln as any kind of common base. So we could write this as log base 7 to the 6th over log base 7 to the, 7 over 3. So what I'm saying is, if you find, you can write this as any common log base 10, log base 3, log base 7, log base 5, as long as you have the same thing here on the bottom and top. You can't switch the 6 and the 3. What else can we do? We can write this as log base 6 over log base 3, because when we don't write what did I say? I said log base 6. This is log base 10. When we don't write the base, it's just automatically 10. Log 6 over log 3 is the same as log base 10 over log base 3. So you can write it like this, or you can leave that out. Okay, just some things to practice with, finding things that are equivalent, using what you know. All right, question number 12, what is the logarithmic form of this equation? So we're just going back from exponential to logarithmic. So this is log base 3, 14 equals x. This number to the right is always going to be our exponent. Let's try one more. Log base 4, 9 equals x. All right, I'm going to give you another look at this one. I think this is probably going to be the hardest one for you. But slow down and take your time and don't rush through this. Use your notes. We talked about this earlier. When there's not a base here, this is log base 10. So this is log base 10, 16 over log base 4. All right, it's not going to be this one. We can't just divide 4 into 16. This is log E, Euler's number for the natural log, but that's not going to work. We can change this to a common base. We just put that 5 in there. We have the 16 on the top and the 14 on the bottom, so that's a yes. Okay, we know that the quotient rule for logarithms, we can write it as subtraction, and even though we change this to the natural log, it's still the same thing. So this is a yes. Log base 4, 16. That's going to be a no. That would be 4 to the x equals 16. No. Log base 16, 4. I don't think that's correct either. All right, I think that's it. All right, think about what you have done in this lesson, what you do well, what you need to go back and review before taking your exam. Take your time, do your best, make it count. Finish all course materials, ready or not. Any amount of points is better than 0 points, and it can make all the difference. Complete your unit tests first, parts 1 and parts 2. Part 2 counts most, so I would go there first. Look at my feedback, look in the I Can, but don't waste your time going online to look for answers. It's going to be much faster if you listen to my feedback. And then use the help in the I Can for the part 1. Do test corrections if you can. Remember, quizzes count the least, and I can go back if you do well on your test and exempt you from some or give you credit if you show mastery on your test. Pay close attention to the course materials. If you're not getting into the course, you're struggling a lot more than you need to, and we want to improve on that. You're missing out on a lot of information. Finish your notes and turn those in, and good luck, everybody. I know you can do this. I'm rooting for you. All right, I will not be available after this week, so make full use of Help Lab and office hours. And if you have extenuating circumstances, don't use email as text. That takes up too much time. I just can't get back to you quick enough. But if you can't see me during office hours or during Help Lab because of special circumstances, reach out and try to schedule a one-to-one and let me know when you're available, and I'll try to make that work if I can. All right, this is the last week I'm available in person. Keep your grades. The aim is to keep them 75% or better in all of your subjects. On midnight, November 29th, that's going to be when they run the report for exemptions. We will not take a semester exam, as far as I know right now, but let's don't count on that. If anything changes, let's be prepared. So let's try to keep our grade 75% or better. So here's last year's review, another review that you can use to help you, okay? All right, good luck. Thanks for coming.